In this example, we continue to practice the separate and integrate method. And we also have boundary conditions, and we have some amount of context, but not too much. So we're told that the height above ground 8 meters of a passenger on a roller coaster can be modeled using the differential equation in front of us, where t is time in seconds from the start of the ride. Given that the passenger is 5 meters above the ground at the start, show that the following is the particular solution. So we're going to use the standard approach, which is we're going to separate and integrate. So we're going to group the 8's with the d8, so we'll end up with 1 over 8 dh is equal to 1 over 40 cos 0.25 t dt. So that is the separate part. Then we integrate. Afterwards, we're now going to get ln h on the left-hand side. When we integrate cos, we get minus sign, we get sine, and of course we divide by the derivative of the argument. So we apply this result that the integral of cos kx dx is equal to 1 over k sine kx plus c. So we're going to have 1 over 40 times 0.25 times sine 0.25 t and then plus c. When we simplify, we're going to have ln h is equal to 0.1 sine 0.25 t plus c. So we're now going to get rid of ln by exponentiating both sides to base e. So we're going to have the following. So we're going to simplify. So we know that e is the opposite to ln. So this is going to be h is equal to a e to the 0.1 sine 0.25 t. Since e to the c is the same as a. And that completes the first part. So again, taking a big picture view. We have the following. So we have the question here. Show that h is equal to 5e to the so here now we now need to include the specific condition, the initial condition. So we know that when t is equal to 0, h is equal to 5. So when t is equal to 0, 5 is equal to a e to the 0.1 times 0, since the sign of 0 is 0. So that means 5 is equal to a times 1, which is a. So therefore, if we conclude, we have h is equal to 5e to the 0.1 times sine 0.25 t. Hence proven. So now if we go to the part B, we want to state the maximum height. Notice that this is only 1 mark, so they're expecting us not to do a significant amount of calculation. So the maximum height of h will occur if we look at what we have. The maximum height of h will occur when we have the maximum value for sine, which is 1. So maximum h is equal to 5 e to the 0.1 times 1, which is going to be 5 e to the 0.1. You can leave that as is, or you can type in that into your calculator 5 times e to the 0.1, which is going to be 5.53 meters. Do include the units for length if you know when you're given questions about height or depth or length or width. All right, so this concludes this example for differential equations.